All right, binomial expansion. So this is a term, this is an expansion, or it's a mathematical expression which has two terms. Expression, mathematical expression, not any just other expression, but mathematical expression with how many? With two terms, which has what? Two terms. For example, if you have a plus b, everything to the power n. So this is your first term, this is your second term, then raised to a certain power or exponent. So this whole term is called a binomial. Why is it a binomial? Because bi means two. So this has two terms. This is a term and its second term. So this term that you have in a mathematical expression is what makes it to be called a binomial, a binomial in short, yeah. Not a binomial expansion. Now, what if they ask you to expand this binomial that you have? Expand it. Very easy for you to expand it. For example, if you have 2 plus maybe 2x to the power 2. This is so easy. When the power is small, it's easy to expand, just like using other algebra that we have. So we can expand this by just saying this can be expanded by 2 plus 2x, multiply again back, because 2 means you have to multiply this by the same thing. 2 plus, then you have 2x. Then this can give us, you multiply 2 by 2, again 2 by the other side. So 2 times 2 is 4. Then 2 times 2x plus, which is 4x. Again, you start with this times that, again like that. 2x times 2, it's 4x. Then 2x times 2, it's 4x squared. Then we correct the like terms. Can have 2 plus, we can have 4. Then 4x plus 4x is plus 8x plus c. Then we have 4x squared. This is called the descending order of expansion. Why is it descending? Why is it not descending? Sorry, this is ascending order of expansion. Ascending. This means that this 4 doesn't have term. So a number or a term in the expansion, in the binomial expansion. So this is a binomial expansion. When you expand this binomial, you get this result. And this is a term, so we call this as a first term. This is a second term. This is a third term. So you have 3 terms in this expansion. Now, this term which doesn't have x is called a term independent of x. A term independent of what? Of x. That's how we call it. And this number in front of x and in front of that, we call them coefficients of x and coefficient of x squared. And we can now say, what is the order of expansion? We call this as ascending order of expansion. Ascending order of what? Ascending order of expansion. Why is it ascending? You start with this one. This is same as x to the power 0 plus 8x to the power 1, because it doesn't have a power, start as 1 plus 4x to the power 2. This tells us that the powers of x are increasing by 1. So this is 0, 1, and 2. So this is ascending order. What if it was in the order of, maybe we say 4x squared plus maybe 8x plus 4? This is descending order. This is what? Descending order of expansion. Why is it descending order of expansion? Because the power is decreasing. So you have the highest power of x is 2, decreases and remains with 1, and decreases to the power 0. So this is descending order of expansion. They can ask you, expand the binomial in descending order of x, or descending order of ascending order, or descending order. Alright, let's now see, what if the binomial that you are given has, maybe the power is too big. So it's very easy for you to expand if you have a plus b to the power n. If n is very small, very easy to expand like what we just did. But what if you are given the term, you are given the power which is very big, probably maybe to the power 12, to the power 7. That would be so tedious for you to solve that question, to expand it. So how do you do that? You use now what we call a binomial expansion, or a binomial theorem. How does that work? So this is how it works. So the binomial expansion with a power of positive integer, this n has to be positive, the power, not negative. So this can be equal to, then you start with a. So now we can now start with the n combine 0, then multiplied by a, this same term to the power n, plus then n combine 1, then you begin with a, then the same a minus 1, n minus 1 multiplied by b, plus then we can have n combine 2, then we can a n minus 2 b, plus then we can have n combine 3, then a n minus 3 b to the power 3, plus dash dash dash, then we can now have plus n combine n, the last term, to the power 10, then we can have now b to the power n. That's how you expand the binomial expansion. So n combine 0, a to the power 1 to the power n, then it's decreasing by 1, decreasing by 1. But as n here, there is no b, meaning this is same as b to the power 0. So meaning b is increasing by 1, because here it was to the power 0, now it's to the power 1, now it's to the power 2, to the power 3, until to the power n, just like a. But a is decreasing, the power of a is decreasing by 1, n minus 1, n minus 2, n minus 3. That's what we call the binomial expansion. The condition here is that n has to be positive, should be greater than equal to what? 1. Can be positive numbers or integers, but it shouldn't be 0 or negative integers. That's a condition for this expansion. Now, apart from you knowing how to use this, they can also ask you to find specifically, without expanding the binomial, without expanding into these terms. Like we have the first term, we have the second term, we have the third term, we have the fourth, and the last term, which is the fifth term. Now, without doing all these expansion, they can ask, can you find the fourth term? Can you find the 16th term? Or can you find the 12th term in this expansion? You can just use what we call the general formula. General formula. So the general formula is used to find specifically, it is designed to find a specific term, to find a term on a specific position, which is r, that's a position. That's number 1. Find the 12th term, find the 19th term without expanding the binomial. That's the importance of the general formula. Secondly, they can also ask you to find, the general formula also find the term which is independent. It has to be independent of x. Shouldn't have x. A number which is independent of x, or a term, is maybe you have 4. This term is independent of x. Independent of x means doesn't have the value of x. Maybe 8, maybe 620, not 620x. No, this is dependent on x. But a number independent of x means shouldn't have any x at all. That we use this general formula to find that term. So what is this same general formula we are talking about? So the general formula is given as tr plus 1 equals to, then you have n combine r, then you have a n minus r, b then to the power t r, using the binomial a plus b to the power n. Without expanding this, you can use this general formula to find the term, specific term, or the term which is independent of what? X. Alright, let's now do the last concept that we need to understand under this. So apart from you understanding the binomial expansion we just did, factorials, combinations, you need also to understand the other formula for expanding the. So what if your n is less than maybe 1, less than 0, or if your n is equal to what? Fractions, a over b. So what does this mean? The conditions are when n is less than 0. What numbers are less than 0? Negatives. Or when n is a fraction. So when you have binomials with negative powers or fraction powers, then you don't have to use the other binomial expansion we just wrote. You have to use this other condition. So also the other condition is that when you have a binomial in this form, 1 plus a to the power n, where n can be a negative or can be a fraction, or it can even be positive, but as long as the binomial begins with 1, then this expansion can change into this format now. So you can expand this binomial which begins with 1 as, so if you have 1 plus a to the power n equals to, you begin with 1 plus, then n times a plus, then begin n open bracket n minus 1, then a squared over 2 factorial plus, then you can now have n open bracket n minus 1, again n minus 2, then a to the power 3 over 3 factorial plus dash dash dash. You keep moving like that. So this is your first term, second term, this whole thing here is your third term, this whole thing is your fourth term. So that's how you keep expanding this binomial. It can work properly when your first term in the binomial is 1, or when it is raised to the negative fraction or to the fraction power. You can use that. So that's how you deal with binomial expressions. So let's now solve question to see how we can handle binomial expansion questions.